Welcome to Strength in Concrete, the podcast presented by the Post-Tensioning Institute, recognized as the leading authority in advancing the post-tensioning industry. Today, our host, Tim Christle, is joined by Nick Amico, South Atlantic Major Bridge Lead at HDR Incorporated, for an insightful conversation centered on the world of post-tensioned concrete bridges. With over 20 years of experience in bridge design, Nick shares his expertise on why PT concrete bridges are a reliable solution for diverse challenges, their long-term durability, and the architectural flexibility they offer. Nick also shares compelling case studies of notable projects, his personal journey into bridge design, and what continues to inspire him as a leader in this field. The conversation wraps with some personal insights and advice aligned with workforce development and what a bridge engineering career could look like for today's college graduates.
All right, so welcome everybody to this next episode in our podcast series. Today we're going to continue our discussions regarding post-tension concrete bridges. We've had a variety of other podcasts in that topic, and we wanted to add to that again today. So today we're happy to have a very experienced gentleman to join us for this podcast, and a great industry partner that we've really enjoyed working with through our PTI and ASB committees, and he's brought a lot of his expertise to bear. So today we have Nick Amico joining us. He's the South Atlantic Major Bridge Lead for HDR. He's out of the Charlotte, North Carolina area. So we're glad to have Nick join us today, and one of the reasons I wanted Nick to join us is not only his great deal of expertise in bridge design in various different facets, but again, also a lot of experiences with PT concrete bridges of all different types. And thus far, we've had the input and conversations with people that are from the supplier side, the other type of consulting sides of the equation, and also research development side. We want to get an input here from one of the active designers that's out there working day in and day out with bridges. So with that, I'm introducing Nick, and Nick, welcome to the podcast.
Hey, good afternoon, Tim. It's great to be here. Good to be chatting with you.
Absolutely. So maybe I'll give you a little chance to introduce yourself in terms of just a general overview of your background since leaving Virginia Tech, and kind of your journey that led you to become a bridge engineer, and also some of your general career to this point that puts you in the spot you are today.
Sure. So you hit off on a key point there. I'm a Virginia Tech grad. I was there for a good 6 long years, working on both a bachelor's and master's degree, and I kind of learned while I was at Tech that I was really found myself really interested in bridges, particularly focused on the aesthetic side of bridge design. So found my way into a firm that does primarily post-tension segmental bridges.
Right, and that's interesting how those things kind of evolve, and you get involved in kind of a piece of the industry, and then the beautiful part is you become an SME in that area, and people like me turn to you for some input. So that's the great part. We really appreciate your work you've done on our DC40, our ASB PTI DC40 committee on bridge design. I know you've been a key component on that committee to help us in our current progress of trying to update the FHWA publication on cast in place box girder design, which is a important document for the industry, and greatly appreciate that effort you put forward there. And I also just want to chime in and say, greatly appreciate your service to our country as part of the Army National Guard, and always thank you for that. So,
yeah, thanks, Tim. And it's been a great experience being on these committees, particularly here at PTI, the working with other professionals and putting together materials that can help colleagues and peers across the industry with post-tension design. That manual itself is tremendously valuable, what John Corbin and his team did on the original version of the document, and it's been a great experience going through and updating that for the latest AASHTO code, and we're danger close to get that wrapped up and out to the field.
Absolutely, yeah, it's certainly a big team effort, and we'll get there eventually here soon, and bring some really good updates to that. So I guess one thing I wanted to touch on to start with maybe here as well is you mentioned, your experience with segmental post-tension bridges and things. Just in general, kind of your viewpoint as a designer, what are some of the main reasons you see from your perspective as to why PT concrete bridges work so well as a solution for various bridge situations, which obviously could be spanning over just about anything. But what's some of your perspectives on major advantages of the PT concrete bridges?
Yeah, so I mean, no surprise here. Concrete itself is incredibly durable. It's very durable, long-lasting material that's got really great compression strength. And applying post-tensioning to that allows that concrete to work primarily in compression, which is, again, kind of where it's strongest. Everyone recalls their reinforced concrete professor back in the day telling them that, concrete's great in compression, but bad in tension, right? So, we typically use conventional mild reinforcing to resolve that tensile capacity shortcoming in concrete, allow it to resist tension. But with PT, we really take it a step further by pre-compressing the concrete rather than just adding a tensile resistance. So by applying that pre-compression force with tendons, we can minimize cracking, we can reduce rebar requirements, and ultimately create longer spans with less concrete. And that leads to lighter structures and less material usage and just longer, or better, rather, lower long-term maintenance. The longer span lengths and the shallower structured depths that you can get with post-tensioning compared to just a conventional concrete bridge, it's really also ideal for urban interchanges where your vertical clearance is limited, or river crossings where you can really reduce the number of piers that you have in the water there. But post-tensioning also gives us more flexibility in how we build bridges. Depending on the project requirements and site constraints, we can either precast the bridge components and post-tension them together in the field, or we can cast the concrete in place and still be able to apply all the benefits of pre-stressing through post-tensioning. And that's where, you mentioned, segmental bridges earlier. That's where, we start to get into segmental bridge construction, and you have the options of span by span and balanced cantilever erection, and you can really tailor the construction methods to the needs of the project, reduce or eliminate false work over traffic or railways, and limit the impacts to the traveling public and the environment around the construction site. But really, Tim, one of the big reasons I got into bridge design, I mentioned it a bit ago, was I was really interested in improving the aesthetics of bridges. Concrete it's a very moldable material. It allows us really an unlimited variety of shapes and cross sections, and post-tensioning really complements that, because the tendons can be profiled to follow those complex shapes and really counter the tension that develops where it develops at. So this allows us a lot greater flexibility in design to construct some really impressive, unique, and aesthetically pleasing, and frankly, architecturally challenging projects that you really couldn't do with a lot of other, materials and such in the market.
Right. No, that's true. That's great. That's always been one thing I've leaned on as well, is it's, concrete, has a lot of flexibility in terms of shapes and sizes. And like you said, the aesthetic appeal, and it's not a Lincoln log type of thing. Even though we talk about segmental, bridges and span by span bridges and things like that have an element of pieces to them, the point is it's at the end of the day, the shapes and sizes are almost limitless, and it's amazing what you can do when you're working with concrete material, let alone the post-tensioning advantages, like you said, that they marry together really well, because they're the real yin and yang of a bridge. Is each does what it needs to do to help the bridge succeed and meet its goals. So that's always cool. So, is there maybe a case study in the recent past several years that you maybe wanted to mention a little of your experience with, whether it's a new design project or even a project where you might have done some strengthening with post-tensioning, or whatever it may be? Anything you wanted to maybe chat about that was of interest that you could share on a case study standpoint?
Sure, I'll give you two. So on the new design side, the first segmental bridge I worked on when I joined, HDR about, 10 years into my career was the Marc Basnight Bridge out in the Outer Banks. Now, this is the replacement for the Herbert C. Bonner Bridge that's out over the Oregon Inlet. If you're at all familiar with the area out there on the the islands out there of North Carolina, it is a tremendously difficult site to design and build a bridge. It's a barrier island, right? So to start, the bridge itself is just highly exposed to major storm events, nor'easters and hurricanes. And with that, the bathymetry is just constantly shifting, and the islands it connects are just constantly evolving. There's a great series of satellite photos that show just how much these islands out there on either side of Oregon Inlet moved over the decade preceding construction, even going into construction. It's just truly wild how much that the land is changing out there. But the bridge has a navigational channel as well, which necessitated long spans. But again, being out there in that very exposed condition out on a barrier island, it's a constant exposure to salt spray. So steel was simply not an option. We had a steel bridge before, we weren't doing that again. So concrete was truly necessary here for its durability, but we had to have the long span lengths for the navigation spans. So we needed something. It was 350-foot span lengths, and the only way we were going to get that with a concrete bridge was to apply post-tensioning. So the result of what we have out there is a 2.8-mile-long bridge that sports a 3,550-foot-long precast segmental variable depth navigation unit that was erected using balanced cantilever, and also actually used post-tension segmental piers as well too. So that was a pretty neat feature. But yeah, that project could have only been done with post-tensioning to result in the durable product that the client needed out there. So that's my new example.
Sure.
A more recent example, kind of on the strengthening side, we've got another structure where it's a concrete structure, but we needed to add some additional post-tensioning to it. There was not that accommodation for future PT into this bridge already, but we were able to work with the contractor and develop anchorages and deviators and come up with a very durable post-tensioning solution to add more strength to that structure, both ultimate moment and shear strength, flexural strength and shear strength to the bridge, and you pretty much regain the original intended service life, again using post-tensioning to add that strength. So really neat project.
That's cool. Yeah, that's very cool. And I know it was won some awards for sure, and very creative solutions and things like that really are always great to spotlight. So I agree, that's some neat perspectives. And even like say you talked about the North Carolina project there. I mean, that's one of those examples of a situation that comes along. I mean, there's bridges of all types and all different scenarios, and they all, like you say, have their own project restraints and constraints that are causing it to need to meet certain criteria. And it's always nice to see that we can find a solution, in these cases using a PT concrete solution, to accomplish those goals, and not only think about building the new bridge or dealing with something right here and now, but then making sure that it lasts the test of time. So I'd imagine most of the times you're dealing with a project, the 100-year service life is obviously a project goal that comes along, at least 100-year service life. And people are very concerned about resiliency and durability, and making sure that, when they're spending all this money on a brand new bridge or doing whatever they are to maintain a bridge, that they're going to get the biggest bang for their buck and have it last a very long time. So, I mean, is there thoughts you have on, again, the comparison of from, say, the year 2000 till now, and all the different things that have gotten better and better with PT bridges, and even what's forthcoming in the next, say, 5-10 years that you see with even other technologies on advancing PT bridge resilience and durability?
Oh, sure. Well, I guess first off, I mean, I'm sure you've seen the ASB Bridge Durability Survey,
Yep.
which really shows the strengths that post-tension bridges have is in terms of durability, right? The vast majority of our segmental bridges, post-tension segmental bridges, have performed extremely well. That said, there have been some things that we've learned as an industry since some of the structures of the 80s and 90s. And quite frankly, a bridge that's built today is going to be far more durable than even those that were built, 20, 30 years ago. Compared to back that time, the 80s and 90s, we now have much more rigorous construction, design, and material specifications. We've got better performing, more durable grout products. We're using much more frequently using plastic ducts. We have we've introduced the concepts of protection levels, which I believe you had a conversation with Brian on in your last podcast.
Yeah.
We have training now that's required of our personnel that's installing the post tensioning, and also of our personnel is doing the grouting. So we have really improved from design through materials through construction, really improved the product that we're giving a client in terms of post tension structures from what we had just a couple decades ago.
Right, right. And the other thing too is in those instances where an owner's got a bridge that's been performing pretty well for quite some time, but they may have encountered a couple issues here or there. And today's mechanisms and opportunities to remediate this or that are again light years ahead of what they used to be, and it's much more easy to achieve some of those touch-ups, I'll call them, and extend the life of a bridge even further than one would have imagined 10, 20 years ago. And so I think that's also evolved as well. And it's nice to have that in people's back pocket, knowing that, hey, this is not this, insurmountable task to try and handle a couple different issues and move things forward. Because with any structure, let alone bridges, I mean, obviously it's a major investment. I know, for example, at NCBC, we're spending a lot of time recently talking about stewardship of bridges and the idea of, overall life cycle and remediation steps and maintaining that asset over a long period of time. And the whole stewardship concept is applicable certainly to any bridge, but in the PT concrete realm, there's so many resources and so many tools that can be brought to bear. It's pretty amazing.
We need to strengthen or otherwise improve a bridge's performance. We can add post tensioning on there, whether it was originally designed for it or not. It is doable. We have done it on a number of occasions. So that is an option. It is doable, but also one of the other things that we've really shifted toward in the post tensioning industry is planning for replacing post tensioning, really developing replaceable post tensioning details. Make sure that we have the space on the ends of the anchors, be able to put the jacks on, being able to pull the tendons out using because we use flexible filler instead of cementitious grout on internal tendons. We've taken all that into consideration now. So
right. Yeah, you're right. That's actually true. That's another thing with replaceability, and it's kind of something almost born out of the nuclear industry from years ago when they had tendons that are in an unbonded environment where they can be the steel strand can be replaced over time if needed, and that evolves and works its way into the bridge world, and replaceability and monitorable tendons and things like that are also a big part of the industry that wasn't there before, and it's constantly improving and evolving. So that's always neat. I guess kind of. Oh, go ahead. No.
I was going to say, one other thing I think is pretty cool and what I'm kind of excited about. Well, first off, the monitorable tendons. I love that. I like being able to understand, what the health of my tendon is. Usually never really an issue, but knowing that I can go out there and actually plug onto it and know what its condition is gives me a lot of kind of comfort, excitement there. But then as we talk about this, the post tensioning itself, Yeah, we recently, actually this year, 2025, we had our first two applications of unducted tendons,
Hmm.
unducted post-tensioning tendons. The first being in the Wando River Bridge. It was part of a tendon addition in that structure, where we used greased and sheathed, individually greased and sheathed strand. Um, just same kind of material that you would use in in a lot of cable stay bridges. And then you have the Laurel Fork Bridge from Federal Highway Administration and Harsey and Hanover. That was they used a flow filled epoxy strand on that. So um, the flow fill epoxy strand in particular adds a whole additional layer of durability onto the strand that I'm excited about, and we have plans on implementing that in some of our future designs.
Oh yeah, no, it's true, and it's yeah, like I said, that's like almost like any technology. It seems like it's evolving every 6 months, or something new that's kind of been tweaked or come along to add to the library of options. And yeah, we've had other discussions. We'll be having actually a PTI webinar here soon about new technologies in PT concrete bridges, and we'll talk about those EIT things and epoxy strand and the fiber optics and all those other cool things. That's the cool side of I guess our little nerddom. Some people might see some of that as being amazingly on a microscopical level of monitoring every foot and every inch of a tendon, but it's part of it. And it's really cool to be able to have those tools. So it's really kind of neat. So I want to kind of draw us a little closer to the end here, but I was just thinking to myself, if you were to come across a Virginia Tech Hokie senior student getting ready to finish up their term there and get into maybe the PT bridge design world, what kind of advice would you have for them, and what are your, again, perspectives for the next decade or so for someone who's just getting started in the bridge industry and maybe following in your footsteps?
Wow. All right. I got to think about this for a minute. So, all right, students, I think need to understand one. They're right now, as they're going through school, they are really developing the basis, the background of engineering knowledge that they're going to build on in their career. Companies do not expect you to come in on day one knowing everything. They expect you to be to learn while you're on the job. They're applying the engineering principles that you gained in college, but there's a reason why your license is engineer in training or engineering intern for the first couple of years. But during that time, really take it all in, understand what it is that you're working on, ask questions, but also try to figure some things out on your own too, because you're going to learn a lot by digging through the code and just trying to nug it out and figure it out. Um, but you'll quickly gain an appreciation, understanding of the design concepts as you actually get into the work. But the other big thing I really encourage students with is to get involved, to find a way to build your network. When you come into a company, of course, as a new engineer, you're going to start building your network by those around you and those that you're working on projects with. But particularly if you're in a larger firm, look for opportunities to engage with folks, across the company. At HDR, and I know a number of other large firms have this too. We call technology centers, where it's just a group of engineers who are interested in a particular topic. They get together about once a month, and they discuss examples of that particular topic or what might be coming out in the industry. So, for instance, we have a post-tension segmental bridge group at HDR. And each month we get together and talk about a project, or we talk about flow fill strand, or we talk about EIT tendons, and somebody kind of leads that discussion, and we all nerd out on bridge stuff. But it gives you an opportunity to really get to know other people from outside of your own tiny little bubble there, and that helps you out as a young engineer, because now you have more resources you can go to if you've got questions, or you need help, or you're looking for an opportunity to go work on this other project over here, or getting some help to work on your project. So it's just building that network. But as you take that next step, you get into your PE, or rather you get your PE. It's now start looking beyond, just your company there, and get involved in organizations like, PTI and ASB. We got great committees here. They're doing great things for the industry, and you don't need to know everything to be on the committee. They're looking for help. Everyone's busy, and if you've got time to help a committee out and producing something, they will take it. They will accept your help graciously. It's really easy to get on these committees. You just have to, frankly, find something that interests you, ask, get involved. And in addition to giving back to the industry, you'll be building your own network, meeting great folks like, Tim Christle. And it really just, it'll help your career, help you get a lot more out of your career as you go through it.
Oh, that's awesome. No, I'm glad I asked that question because I appreciate your perspectives and your insights on that kind of thing. Because like I say, you're a practicing engineer in a very important industry, and you've not only in your group there at HCR, but others. There's the senior level people that have been there, done that, and have got some of the gray hairs to prove it. And then there's the brand new people coming in fresh, and we all know that there's the people that have learned how to do things by hand and the people that only know computer software, and it's everything in between. And it's just always a fascinating thing to think about, and just overlaying that with the PT Bridge world and design and everything. The resources are amazing. What you talked about as far as networking and collaboration is amazing. And so, even though I'm personally getting closer to the end of my career, I hearken back to, things I've learned, and all of us want to pass that along to the next generation and continue to have really cool bridge designs and bridge construction, and there's so much limitless opportunity down the road. So that's really cool to have your perspective on that. So, well, again, appreciate it, Nick. I know this was just kind of a chance to chat a little bit about some highlights and key points. So appreciate again your time with us today on this podcast, and also again all your efforts helping advance our standards and guides and everything else we have coming from PTI and other organizations. And so greatly appreciate it, and looking forward to all those future endeavors as we go forward. So
appreciate the time. It was good chatting with you, Tim.
All right. Thanks a lot, Nick.
Thanks.
Thank you for joining us today on Strength in Concrete, brought to you by the Post-Tensioning Institute. We hope today's discussion provided you with valuable perspectives on the advancements and opportunities shaping our field. If you would like to deepen your knowledge or explore additional resources, we invite you to visit our website at www.post-tensioning.org. If you enjoyed this episode, be sure to subscribe to Strength in Concrete on your favorite podcast platform and enable notifications so you never miss an update. Until next time, this is Strength in Concrete, your trusted source for post-tensioning expertise. We look forward to connecting with you next time.